Okay, so yesterday we were working on this problem, and we were trying to minimize the amount of wire, and the wire was basically Z and Y. We want to minimize that. It's got to stabilize both of these poles, and we were going through how you do optimization, so maximizing or minimizing problems. We talked about primary and secondary equations. Primary equation is always the equation that you're minimizing or maximizing, and that's the one that you're going to take the derivative of, and this, like I said, this goes right into curve sketching because we're finding maxes and mins in curve sketching. So this is an application of curve sketching. Okay, so yesterday we basically found that y, which is this, is x squared, which is this little piece right here, plus 144, which is 12 squared, is equal to y squared. So y is the square root of all of that. Everybody with me on that? Does that ring a bell? Z is 30 minus x, which is this portion here, squared, plus 28 squared, which turns into 784, is equal to z squared. And then we take the square root of it all, and this is what we get for z. All right, now the wire, the amount of wire that we're looking for is y, this plus this, y plus z. All right, so let's write that out. So y is the square root of x squared plus 144 plus z, which is the square root of 30 minus x squared plus 784. All right, now that's our equation. We've used a primary equation, we used the secondary equation, and we've got this into one variable. That variable is what? X. So we're good. We're happy with that. Now the next step, and so where we're at, if we look at this, we've written the primary, we've written the secondary. Can y'all see that? Okay, now we've got to determine the domain. And so what is our domain? What are we talking about? Which variable, x, y, or z? X. So what is the smallest that x could be? And look at our drawing right here. What's the smallest that x could be? The smallest that x could be would be 0, right? In fact, it could just come all the way over to here. Does that make sense? Okay, it's not going to be because but as far as mathematically goes, that's as small as it's going to get. What's the biggest? 30. Okay, so our domain needs to be between 0 and 30, and those are our two endpoints. Okay, so endpoints, I'm going to write this down. Or 0 and 30. Is everybody okay with that? That may be the trickier part of it. Okay, so now the next step, step 5, is to find critical numbers. How do I find the critical numbers? How do I do that? Derivative of this. So I'm going to call y or w now. So this is w prime is equal to, and I want to take the derivative of all of this. So I'm going to rewrite this up here so I can look at it. Okay, so 2 chain rule problems. So I'm going to start with this one. That's going to be 1/2 times the inside, which is x squared plus 144. Take 1 away from there, that's negative 1/2, times the derivative of the inside, which is what? 2x. Done with that one. Now this one, plus 1/2 times the inside, which is 30 minus x squared plus 784, to the negative 1/2 times the derivative of the inside, which is what? It's another chain rule. So that's 2 times the inside, which is 30 minus x, to the 1 times the inside of that, which is what? Negative 1. Yeah.
It could be worse. It could be worse. It will be worse.
There you go.
Okay. Let's clean up a little bit. So this is going to be 1/2 times 2x leaves me with just what? Just x, and that's on top, over x squared plus 144 all to the 1/2. Everybody good with that first part, what I just did? Plus, okay, I'm going to deal with this 1/2 and this 2 and this negative 1. What is 1/2 times 2 times negative 1 equal to? Negative 1. And then that's negative 1 times 30 minus x, which was left on top. Everybody with me on that? Over 30 minus x squared plus 784 all to the 1/2. Everybody good? Okay, I got to solve for x, right? I got to find out when x is equal to 0. So what is the best? What should I do at this point? Anybody got any ideas? I'd love to have a common denominator. That might not be the easiest way to go about this problem, but at some point I'd like to be able to isolate x and factor it and do that sort of thing. So what I'm going to do is this is all equal to 0, right? Because I'm finding critical numbers. I'm sending this whole thing over there. And I'm going to end up with 30 minus x over 30 minus x squared plus 784 all to the 1/2. And that's equal to x times, or x over x squared plus 144 to the 1/2. Now, I want to cross multiply. Okay? So this is going to end up being 30 minus x times x squared plus 144 to the 1/2. And that's going to equal x times 30 minus x squared plus 784 to the 1/2. Okay. Now, you ready for some more fun?
Yes.
I gotta get rid of those 1/2s. What do I do? I'm not gonna square root them. I'm gonna square them. Squaring everything. Okay, so this turns into 30 minus x squared times x squared plus 144. And this turns into x squared times 30 minus x, all of it squared, plus 784. All right, now I'm going to hopefully make this. Hopefully, we'll work this out and everything will look good. What is the square of 30? 30 times 30 is what? Anybody know? 900. Then I have 30 times x, negative x, plus 30 times negative x gives me negative 60x. And what's the square of negative x squared? X squared.
Can you move the paper, please?
So all I did was FOIL this. That's FOIL. X squared plus 144. And then this one is x squared times, and this turns into, you guys want to take my word for all of this whenever I,
Yes.
okay, this is going to turn into 1684 minus 60x plus x squared. Okay, now I've got to multiply this out. So this is x to the fourth, that's x squared times x squared, minus 60x cubed plus 900x squared. So that's taking all of these and multiplying by x squared. All right.
What about 144?
Plus 144x squared minus 8,640 x plus 129600
My God.
is equal to 1684x squared minus 60x cubed plus 60x to the fourth. Okay.
Unfortunately, that's all.
I'm sorry, that shouldn't be 60x to the fourth. That should just be x to the fourth. Sorry, Stephen. I know you're a stickler for that stuff. All right. I have an x to the fourth over here and an x to the fourth over here. What do? They do the hokey pokey. I have a negative 60x cubed over here and a negative 60x cubed over here. What do? They cancel also. And I'm left with, if I rearrange everything, so I'm going to send that 900 over here. I'm going to send that 144 over here. I'm going to send everything over there, actually, is what I'm going to do. I end up with 0 over here. I end up with 640 x squared plus 8,640x minus 129,600. All of those are factorable by 320. So this turns into 2x squared plus 27x minus 405. And now what do? Factor those. So that's 320. This is 2x plus 45 and x minus 9. So what are my zeros? Anybody know? What is negative 45 divided by 2, or does it even matter?
Doesn't matter.
Why not? Because you guessed? Why doesn't it matter? What's our domain? 0 to 30, so doesn't matter. Not in domain. Okay, so here's a possible, and where are my other possibles? band points. So I need to find W of 0, W of 9, and W of 30. And I want the smallest. So I'm going to go back to my original equation. Okay? And the original equation was this right here. Everybody see that? I'm going to plug in the x value. So when I plug in 0, I get 12 plus 900 plus 784. Okay, which is something. Okay, so I plugged in 0 and I get 53.037. That's how much it would take. Okay, if I plugged them all into this original equation. Plug in 30, I get 60.311. So which one is the smallest so far? 0. If I plug in 9 though, I get 50.
50 flat.
50 flat.
That's my 40
50.
That's the second.
All right. So that's my min right here. And that's my answer.